Hi, in this video we will explain another example of divide and conquer techniques. We will study this problem. This problem is called counting inversions, and we'll try to solve it with divide and conquer techniques. So this problem, let us give you example. Imagine you have a music site, and the music site try to match your song preference with other. So this site asks you to rank n songs. So imagine the site give you 5 songs. So you need to rank them, which one is the most preferred for you, which one is the next, and so on. And the site will match your ranking with the other ranking. So the music site consults database to find people with similar taste. Now, how to know that two people have similar taste? One measure is to count the number of inversion between the two ranking. So imagine you have this rank 1, 2, 3, 4 till n, and someone else has another rank A1, A2, A3 till AN. So one way to know how similar the two ranks are is to count the inverted numbers. So here is example to see the inverted numbers. Imagine this is your rank 1. So you like song A the most, and then song B, song C, and song D, and song E. But someone else like song A the most, song B he likes number 3, song C number 4, song D number 2, song E number 5. So how to compare these two ranks? One way is to count how many inversion is there. For example, here there is inversion between 2 and 3 and 2. Why is this? Because this one he likes 2 before 3, but this one he likes 3 before 2. So this is one inversion, the 2 and 3. Another inversion is the 4 and the 2, right? So here this guy like 2 before 4, but this guy he like 4 before 2. So these are the only two inversion in these two ranks. So our goal in this problem to count how many inversion between the two lists. So we will be given two lists, and when we try to count the inversion. If we use brute force techniques, for sure we can use brute force technique, and we check all the pairs. Like we check 1 with 3, there is no inversion, right? 1 and 4, there is no inversion. 1 and 2, there is no inversion. 1 and 5, there is no inversion. And then we try 3 with 4, no inversion. 3 with 2, there is inversion, right? 3 with 5, there is no inversion, and then so on. But this is n square, right? So in this chapter we'll try to find a smarter way, a more efficient algorithm using divide and conquer. First, like this problem appears in many situations, like it appears in the voting theory, in collaborating filtering, even like some in nano parametric statistics. In many fields this problem can appear. So as I mentioned, in this chapter we'll try to solve this problem using divide and conquer. So how to use it using divide and conquer? We have a list. So the first list is like the normal order: 1, 2, 3, 4, 5, 6, 7, 8, and so on till I think 12. And this is the other list. How many inversion we have? So we need to count, yeah. So one way is to do brute force, like compare 1 with 5 is no inversion, 1 with 4 no inversion. 1 does not have inversion with anything, right? But 5 with 4, for example, we have inversion. Why? Because 5 appears after 4 in this list, right? Because this list is ordered. Anyway, our goal is to count the number of inversions. So we can do brute force, but this is n square. We want to do something smarter. The smarter is the divide and conquer. So in divide and conquer, first step is just divide this array into 2 arrays. Okay? And then what we will do, so divide and try to find the number of inversion in each part. So here we will do again, we will divide this small array to 2 arrays the same way like we did in merge sort. But assume that we continue and we know that for this blue part we have 5 inversions. Actually these are the inversions. How did we know? Imagine you continue the algorithm and you know. And in the green part you have like 8 inversion. So these 8 inversion only in this green part. So now we divided the array into 2 arrays and we count the inversion in each half. But this is not enough, right? We need to merge. We need to see, because sometimes there is inversion between this half and this half. For example, this inversion 5 is before 3. So this is inversion, right? So we need to count how many inversion between the blue and the green. In this example, we have 9 inversions. Okay? But now the question, we need a nice algorithm to do the combine. Okay, we know how to divide, it's easy. We know how to recursively divide so we can conquer. But we need to combine the result. Imagine we know that we have 5 here, we know that we have 8 here, so we need to combine the result. We cannot add 8 plus 5. We need also to consider this type of inversions. So the total will be 5 plus 8 plus 9. How to find these 9 in an efficient way? This is the question. So to find this in a nice way, actually, we have to a little bit modify our algorithm. So we need to use sorting. Because if we have 2 parts and they are sorted, like this part is sorted and this part is sorted, then it's easy. We can easily count the inversion between this half and this half. How is that? We take the first element here, okay, the 2. We know that the 2 is just less than the first element in the other half. So we know that all these elements have inversion. So in total we have 6 inversion for the 2. Okay. 11's appear here. So we have these 3 numbers as inversion for the 11. 16, we have only these 2, and so on. So if the 2 arrays are sorted, it's easy to compute the number of inversion between the 2 halves. It's big O of n. So this is the idea now. We can merge using big O of n. So, and again, we can use the same way we use in the merge sort to have sorted array, like we have 2 pointers and merge the 2 pointers the same way like we did, so we can get a sorted merged array. So we can, to count the inversion, we need big O of n. To merge the 2 sorted array in a sorted array, we need also big O of n. So to put everything together, here is the algorithm. So we need to sort and count. So sort and count. If list L has one element, then we return 0. There is no inversion. This is the best case. Otherwise, if we have a longer list, we divided the list into two halves, A and B. And then what we do is that we sort and count the first part, A. We sort and count the second part, B. And then we merge and count the two parts. And then we return the number of inversion in A, number of inversion in B, and the number of inversion between A and B in the sorted list. So this, as you see, it will be n log n, because we need big O for the divide. To conquer, we need 2tn over 2, same like before. And for merge, we need big O of n. So it's the same like merge sort, so we can use the same analysis and prove it's n log n, which is much better than n square for the brute force. Thank you for the listening, and see you in the next video.